This brain starter asks you to find sine, cosine, and tangent when the point is negative 8, 15. The first thing you should do is create a right triangle out of this. Now, since negative 8 is the x value, that would mean that this side is 8, and the height here is 15. So, in order to find the hypotenuse of this triangle, you have to use the Pythagorean theorem. When we use the Pythagorean theorem, you see that the hypotenuse is 17 units long. So, now we can solve for sine, cosine, and tangent. And don't forget that some of these will be negative. Pause your video now so you can do the problem. Since sine is the y value over r, which is essentially the radius, the ratio is 15 over 17. Cosine is the x value over that 17, so that's negative 8 over 17. And tangent is the y value over the x value, so it's negative 15 over 8. If you have an angle in standard position, which we'll call theta, then a reference angle, which we're calling theta prime, is the acute angle that's formed between the terminal side of the angle, that would be this, and the x-axis. And yes, it's always the x-axis. So you see in quadrant 2 here, this is the reference angle. In quadrant 3, this is the reference angle because it's between the terminal side and the x-axis. And over in quadrant 4, this is the reference angle because here's the terminal side and here's the x-axis. You can find the reference angle just by figuring out how far away your terminal side is from the x-axis, or algebraically, there's also rules for it. So, I'll set up an angle in each one of these quadrants and show you how the rule works. For quadrant 1, I choose the 45-degree angle, and since the reference angle is just the same as the original angle, well, that will just be 45. For quadrant 2, the original angle is 135. The reference angle is right here. So using this rule, we have to do 180 minus 135, which gives you a reference angle of 45 degrees. For quadrant 3, this is the reference angle, and the rule is the reference angle minus 180. Since 225 is bigger than 180, we would subtract the 180 to get a positive reference angle. So, 225 minus 180 gives you, again, 45 degrees. Well, it's almost like I planned it this way. And then, the final reference angle we're looking for is right here, and it's for the angle of 315 degrees. And essentially, this is like 315 degrees here, and this is either 0 or 360, so it's easier just to do 360 minus the original angle. So when you do 360 minus 315, surprise, surprise, the reference angle is 45 degrees. That means that each one of these original angles is 45 degrees away from the x-axis. Tomorrow you'll see how this applies to trigonometric ratios, but for now we're just going to focus on finding the reference angles. For the two problems below, you have to state what quadrant each of the original angles is in, and name what its reference angle is. So, for the first one, it's 300 degrees, and the second one is negative 2 pi over 3, which is in radians. Here I've drawn the angle of 300 degrees in black, and the reference angle is in red. Pause your video now so you can figure out what the reference angle is for 300 degrees. Since 300 degrees is in quadrant 4, that means we'll be looking at 360 minus theta. So in that case, the reference angle is 360 minus 300, which gives you a reference angle of 60 degrees. For negative 2 pi over 3, this is the angle right here drawn in black. Now, it's a little easier and these rules apply better, and actually work well, if we convert this to a positive degree. So, remembering that the entire circle is 2 pi around, we can just do 2 pi minus 2 pi over 3, and we can find what that is in positive degrees. So converting 2 pi into a denominator of 3 would be 6 pi over 3 minus 2 pi over 3, which gives you an angle of 4 pi over 3. Now let me redraw that for you. Wow, that was magic! Okay, so now we can work with this. We know that the angle is in quadrant 3, which means we're going to use this rule right here. And remember, this is the reference angle we're finding, the acute angle between the terminal side and the x-axis. So 4 pi minus 3, or over 3 rather, minus pi, which I'm going to rewrite as 3 pi over 3, because that would cancel out and give you pi. So subtracting that, we get that the reference angle is simply 1 pi over 3.